Hello, and welcome to this tutorial on looking at trigonometry for the GCSE spec. So trigonometry is all about right angle triangles. So whenever you see any triangle that contains a right angle, you can always apply trigonometry to it. Okay, and trigonometry allows us to be able to solve for things as long as we know two other things, essentially. And trigonometry is split into three functions. So we have the sine of some angle, which we're going to call theta. This, just as a side note, this theta is just the Greek letter that I'm going to use to represent an angle. So this angle here might be theta. Okay, so sine of that angle, if we perform the sine function on that angle theta, it's equal to the opposite divided by the hypotenuse. Cos of theta is equal to the adjacent divided by the hypotenuse, and tan of theta, which is equal to the opposite divided by the adjacent. Okay, so these are your three functions that rule all of your trigonometry formulae. So this is, if you haven't seen trigonometry before, will be a lot of new words. What is opposite, adjacent, hypotenuse? How do we label things? So that's the first thing we're going to go through, is how do we label the sides? Okay, so whenever you approach any trigonometry question, the very first thing you do is to label the sides. So let's take this right angle triangle here, where your right angle is here, and let's call this the angle theta now. Okay, so it's in a different position. If we now call this the angle theta, the hype, meaning the hypotenuse, is always in the same place. The hypotenuse is always the longest side of your right angle triangle. It's always the one that's opposite of your right angle. So the slanted one is your hypotenuse. Okay, that one's the easy one to be able to recognize. Just the slanted one that's opposite your right angle. Now, having the opposite and the adjacent, so these two actually depend on the position of your angle. So in this case here, because our angle is in this top corner, if we use the literal meaning of the word opposite, we're looking what is the side that is opposite of this here, of this angle. So in this case, this side here is the opposite, and this side here is adjacent, because it's I mean literally adjacent just meaning next to. The adjacent one is next to that angle, opposite one is opposite the angle. Okay, so this is how we can label our sides. It's always the first thing you want to do, and just to be sure that we've got this, we could draw a different kind of right angle triangle. Let's say we had a right angle triangle that looked like this instead, where this one here is actually your angle theta. Well, if we wanted to label the hypotenuse first, it's always the longest one opposite the right angle. So this one here is your hypotenuse, because it's opposite that right angle there. Then you want to look opposite your theta angle, which is going to be there. So this side is going to be opposite, and that leaves this side as the adjacent. Okay, so now we can name the sides that we've got. So how do we go from having these sides to being able to choose which formula we're going to use? Well, in all questions, they will say something along the lines of maybe here is a triangle, and they will tell you that this side is maybe 10 centimeters and this angle here may be 30 degrees, and they want you to work out this side here. So choosing your equation is dependent on what you've been given in the question. So in this case, the first thing we do when we approach this is label the sides. This side up here, since our right angle is here, the 10 centimeters is your hypotenuse, and the x is opposite to that 30 degrees. So we have a hypotenuse and an opposite. Now, remembering all three formulas and writing them out every single time you do a question is going to be long and probably not easy to be able to memorize. An easier thing is using this tool, which is a SOHCAHTOA. Okay, so remembering the phrase SOHCAHTOA is a lot easier than remembering sine of theta is opposite over hypotenuse and so on and so on. Now, the way I've drawn these is to try and show you that, I'll take the sine example for this one, that sine of the angle is the opposite on top and the hypotenuse on the bottom. That's why I've drawn the opposite up here and the hypotenuse down here. Okay, so the first thing you want to do is to write out or recognize what sides you have. The second thing then is to look at your three formulae and say which one can I actually use to solve for this. So if we currently have the hypotenuse and the opposite, the only one that involves both the hypotenuse and the opposite is the sine function. So we're going to say that sine of the angle is the opposite divided by the hypotenuse. Okay, and now we can solve this. So this is going to be solving for sides. So the first kind of question they can ask you is to solve for a side. Now, the values we know here, we know that theta, so the angle here is 30 degrees. So sine of 30 must be equal to the opposite, which we know is x, divided by the hypotenuse, which is 10 centimeters. Now we're going to use this, and we're going to rearrange to get x. If we have x divided by 10, if to rearrange it, it's going to become x is equal to 10 times sine 30. And if you then put this in a calculator, 10 times sine 30 is going to give you 5 centimeters, and therefore we've solved for that side. So solving sides is the easy half of trigonometry. Let's now take a little half of this, and now let's say what happens if we wanted to solve for an angle, because we know this these equations, these three trig equations, can be used to solve for sides or angles. So let's take a right angle triangle here, where we're going to have the angle, let's keep it here, but I'm going to call it theta. Sometimes they'll call it x, sometimes they might call it g, f, h. It all means the same thing. And let's say they tell you that this side is 3 centimeters long and this side is 4 centimeters long. And they want you to work out what is the value of theta. So this is solving for angles. Okay, so now solving this, the first thing we want to do every time is to label our sides. So we know instantly that this is the hypotenuse. This 4 centimeters is opposite of that. So this is the opposite and this is the adjacent. And now when we look up here to SOHCAHTOA again, if we look, the sides that we have are adjacent and opposite, and the only one that has both opposite and adjacent is a tan. And so if we take tan of theta is equal to the opposite divided by the adjacent, we're then going to have to substitute in everything that we know. So we know that the opposite and the hypotenuse, so we can say that tan of theta, which is still unknown, is going to be equal to the opposite, which is 4 centimeters, divided by the adjacent, which is 3 centimeters. And now we want to solve for theta. And the way we did the solving sides is we rearranged to make theta the subject of the formula. Rearranging for theta in this case is going to involve us performing an inverse function. So if you remember when we are rearranging equations, if we have a multiply on one side, it becomes a divide on the other side. In this case, not only do we have the functions of sine, cosine, and tan, but we also have the inverse functions of those. And you can see those written. So the inverse functions will be written as sine to the -1 of something, or cos to the -1 of something, or tan to the -1 of something. And these are your inverse functions. And you can get to these just by doing shift and then either sine, cosine, or tan on your calculator. Okay, so if I want therefore to move the tan to the opposite sides of this, I need to perform an inverse tan function, because it's the opposite of a tan function. And that means that therefore theta must be equal to the inverse tan, so tan to the -1 of that 4/3. Okay, now this is what you would take and put into your calculator. So tan of 4/3, or inverse tan of 4/3, is going to give you about 53.1 degrees, and therefore we've solved for that angle. We now know what that angle is. Okay, so using trigonometry, we can solve for sides, we can also solve for angles. Now, all of this that we've done so far is always going to be using a calculator. However, there are ways that we can get some of these values of having sines or cosines of specific angles that will give us an exact value. Okay, and so sometimes, so if we look at exact values, sometimes it's actually gets easier to know these exact values, and so you can basically cut down the time that you're taking in order to solve the problem. Okay, so there is a table that can tell the exact values of all these trig functions. I'm going to say that I have a sine of theta and a cos of theta here. And I am going to do tan theta as well, but I'm going to leave a bit of space to show you how we get to the tan theta. So the angles that we're going to look at are, what if the angle is 0? What if the angle is 30? What if the angle is 45, 60, or 90? These are your exact values that give you quite nice results. And the way we find out what these are is that we essentially number them. So we say this is sine theta 0, 1, 2, 3, 4. Then we're going to square root that number, or let's do cosine first of all. The cosine theta is going to go backwards of that. So we're going to do 0, 1, 2, 3, and then 4 here. Now we're going to square root all of those numbers. And some of these numbers will only stay as square roots. So for example, the square root of 2 is a surd. We can't really do anything that's the square root of 2. But the square root of 4, or the square root of 1, or the square root of 0, we'll be able to simplify. So we'll get down to the simplifications in a second. But just as a method of working these out from basics, we just number them 0, 1, 2, 3, 4, and then cosine comes backwards, 0, 1, 2, 3, 4. We square root all the numbers and then divide everything by 2. And these give us the exact values. So what this means, the way we'd read this, is let's say that I have a sine of 30 degrees. I look for the sine function, the 30, and that's root 1 over 2, but I know root 1 is actually just 1, so sine of 30 is a half. Okay, and so what you can do with these is it enables you to be able to work out exact values in surd form, which get a lot more useful when you get to higher levels. But let's simplify some of these things. So root of 0 is 0, and 0 divided by 2 is still 0. So this whole sign of 0 is just 0. Square root of 1 is just 1, so I can just leave that as a half. The square root of root 2 over 2, square root of root 2 is just square root of 2 even. I can't simplify any further than that. I can't simplify root 3 either, but I know root 4 becomes 2, and 2 divided by 2 becomes 1. Okay? And so then you'll find that the pattern of going forwards in sine and backwards in cosine will be the same. So this 0 over 2 becomes 0, this root 1, and this over here becomes 1 here. Okay, so these are your exact values of your trigonometric functions, but it also pays to know the exact values of the tan function as well. But the way we work out the tan function is not as simple as working out the sine and cosine functions, and that's because we have to have an identity. So a tan function, so tan of theta, is actually equal to sine of theta divided by cos of theta. Okay, this is just how we define tan. This is what's known as an identity, really. So whenever we say we've got tan theta, it's because we have sine theta over cos theta. And we could prove this. We could say that this is true because we know that what we've just said is that tan of theta is the opposite divided by the adjacent. And that's because if we put in sine of theta is the opposite divided by the hypotenuse, and if we divide that by cos of theta, which is the adjacent divided by the hypotenuse, when we divide fractions, this becomes the opposite over the hypotenuse times the hypotenuse over the adjacent, and then the hypotenuses cancel, and so we just get that sine theta over cos theta is opposite over adjacent, meaning that that must be equal to tan theta. So this identity here must be true. Okay, and we can use that then. So let me get rid of this really quickly. So we can use this identity to be able to work out what all of these values are. So if we have a tan theta, and I'll write down here that tan theta is equal to sine theta over cos theta. If I have a sine theta is 0 divided by 1, then tan theta must be equal to 0. If I have 1/2 divided by root 3 over 2, 1/2 divided by root 3 over 2 becomes the same as 1/2 times 2 over root 3, and so this becomes 1 over root 3, but then I want to rationalize this, so this is going to become root 3 over 3. Okay, tan of 45, well, if we have root 2 over 2 divided by root 2 over 2, that's something divided by itself, so tan of 45 gives you 1. And then if I have tan of 60, I have root 3 over 2 divided by 1 over 2, and that's going to become, so that becomes root 3 over 2 times 2 over 1. The 2's cancel, this just becomes root 3. And this tan of 90 is an interesting one, because if I wanted to do 1 divided by 0, if you put anything divided by 0 into your calculator, you'll find that you're going to get a math error. And that's because it's not actually possible to divide anything by 0. It's kind of like saying, I have £3, I want to give it to this 0 people, and it's kind of, where does that money go? It's not possible to be able to share it between 0 people, and so this actually is not a value. And we'll look at how that plays out when we look at trigonometric graphs. But for now, this table is good enough to get us through, knowing that we don't have a solution for tan of 90 because we can't divide anything by 0. We now know how to solve for angles and sides in trigonometry, and this is going to help us when we have a look at the exam questions now. So if you haven't already watched the video on how we're going to solve these questions, I would recommend going back and watching that first, and then we're going to jump into some questions. So we said the first thing we're going to do whenever we have these questions is we have to first label the sides. So we have to label which one is the hypotenuse, which one is the opposite, and which one is the adjacent. Okay, so we said the hypotenuse is the easiest one because it's always the one that's opposite that right angle. So this x here is going to be the hypotenuse. Then the opposite is opposite the angle that they've told us. So that's over here, and that leaves this one down here to be the adjacent. Okay, so this is the very first thing you want to do. The next thing is just to sketch down the SOHCAHTOA, okay, because this is now going to be able to tell us which function, sine, cosine, or tan, are we actually going to be able to use in order to solve for this distance here. And so we can see in this example, we have an opposite, but we also have a hypotenuse. And so the only one of these three functions over here that contains both an opposite and a hypotenuse is the sine function. And so we can say that sine of the angle, which is 35 degrees, must be equal to the opposite, which is 20 centimeters, divided by the hypotenuse, which is x. Okay, now that we've got this equation, we're just going to solve it. Okay, so we need to make x the subject. So we're going to move x to this side by multiplying it. Since it's divided by x on the right hand side, it has to be multiplied by x on the left hand side. So x times sine of 35 must be equal to 20. And then in order to get just x, we need to move the sine 35 to the other side. And so we're going to say that x must be equal to 20 divided by sine of 35. And that's going to be your answer. You're just going to take your calculator and type in 20 divided by sine of 35. And you should get an answer of about 34.9 rounded to centimeters, rounded to 1 decimal place. But you can see in the question, we've been given to 2 significant figures here and also 2 significant figures here. So on your answer line, you can just say that this is 35 centimeters. And therefore you've solved for this hypotenuse side x here. Okay, so this is how we'd solve sides in trigonometry. Now let's have a go at solving for an angle. So again, first thing we're going to do, label hypotenuse, opposite, and adjacent. The slanted is the hypotenuse. This one over here is the opposite, and this one down here is the adjacent. Then if we write out the SOHCAHTOA, we are currently working with a hypotenuse and an adjacent, so that's going to be a cosine since it's the only one that includes a and h. So then we can write out that cos of x is equal to the adjacent, which is 16, divided by the hypotenuse, which is 24. If you wanted to, you could simplify this fraction, but it's really not necessary. So we need to solve for x, and it's currently being put into the function of a cosine. So the cosine function is currently being applied to x. So we need to get rid of that. We need to somehow move the cosine function to the other side. And what we said in the video was that the opposite of a cos function, so if I had a cos of x, the opposite of that would be cos to the minus 1 of whatever's on the other side. So I'm going to move the cos across and say that x is therefore equal to cos to the minus 1, or inverse cos, of 16 over 24. Okay? And then from there, you can just throw that into your calculator by saying shift cos is going to give you the inverse, then 16 over 24, and you should get an answer of 48.2 degrees, But again, everything in the question has been given to 2 significant figures. So this is to 1 decimal place, but that is going to become that x is equal to about 48 degrees to 2 significant figures. And now we can solve for an angle. Okay, so now let's make this a little bit trickier, and we haven't actually been given a right angle triangle in this. We have to be able to observe this shape and know that we can separate this if we draw a line here into a rectangle and a right angle triangle. Okay, so we can see the right angle triangle is AD to this point here, and the rectangle is ABC and then to that point there. Okay, now the question is asking that we want to work out the size of the angle BAD. Now the way we read these is we start at point B, so we're starting here, then we go to point A, which is here, and then we go to point D, which is all the way up here, and we look at the angle that makes. So the angle BAD is actually this total side here, or this total angle even, which I'm just going to note as X just to make it a little bit similar to what we've said before. Okay. Now this angle is being split over a rectangle and over a right angle triangle. So if we were to separate this, let's say that I can separate this angle, and I'm going to just draw the right angle triangle as roughly as I possibly can. And so what we can say is we need to know what this angle here is. Now I'm not going to call it X because X would be the full thing here. I'm going to call this theta, okay, just to show that it's just that part of this whole angle that we need to find, because we're going to have to add it to something later in order to get the total X. So we need to know what the dimensions of 2 of these sides are. Now we know that if this side down here is 15 and this is a rectangle, then this side going across here must also be 15. So we know this side here is 15 centimeters. Okay, and we also know that this side coming up here is 4 meters, and this whole side coming up here is 6 meters. But if this is a rectangle, then up to this point must be 4 centimeters. So what's left must just be, meters, must just be 2 meters. Sorry, this should be meters. 15 meters, and this should be 2 meters. Okay, now we want to label the sides. So this one is the hypotenuse because it's always opposite the right angle. The one that's opposite the angle theta is the opposite, and the 15 is the adjacent. And we want to write down the SOHCAHTOA. So we have SOHCAHTOA over here. Now we're looking for something with an opposite and an adjacent, so that's going to give us the tan function, and tan of theta is going to be the opposite, which is 2, divided by the adjacent, which is 15. And now if we want to work out what this angle is, we have to do the inverse tan, so therefore theta must be equal to inverse tan of 2 over 15. And then we can throw that into a calculator, and if we do inverse tan of 2 over 15, this is actually going to give you 7.59 degrees, which I'm going to say is just 7.6 for this, because we want this to 1 decimal place. Okay, now that's just this angle here. If we want the whole thing, we have to realize that we have to add together this angle theta with this angle in the corner of this rectangle, and we know what we can see here is the angles in the corner of these rectangles have to be 90 degrees, and so we're going to say that this full angle BAD must be equal to 90 plus the 7.6, which is just 97.6 degrees, and therefore we have our answer to that. Okay, now the final question that we're going to go through is one where we have 2 triangles, and we want to work out the size of the angle BCD. So going from what we said before, we start at B, we go to C, we end at D. So this here, I'm going to call x. Okay, so that's our final goal. We want to work out the size of the angle labeled x, but in order to do that, we need to first know two of the sides. Now we have no indication of what the hypotenuse is, so if we label this side, this is the hypotenuse, this is the opposite, and this down here is the adjacent. Now we have no indication of what the hypotenuse is. We know what the opposite is, and the adjacent, we know what this full length of the bottom is, and so we need to try and figure out just the length of the adjacent. Okay, so how we're going to do that is the second triangle is also a right angle triangle, where we know the angle, we know the opposite, because this is also an opposite up here. This is also an opposite for the left-hand right angle triangle. And so we can actually just work out what this length here is. So if I draw this out a little bit more explicitly over here, so I'll say that this right angle triangle is 37 degrees, this is 9 centimeters, and let's call this L. So this distance, or this length, L. We need to, we've already said this is the opposite and this is the adjacent. So if we look at the SOHCAHTOA again, if we have opposite and adjacent, we have tan. So tan of 37 would be equal to the opposite, which is 9, divided by the length L. So L, when we rearrange, we want to take L up to here, but then take the tan 37 down to here. So we're essentially just swapping L and tan 37. So that's going to be 9 over tan of 37. And then we can put that into a calculator and just say 9 over tan of 37 degrees is going to be equal to 11.9 centimeters. Okay, to one decimal place, since that's what we're looking for in the question. But if A to D is 11.9 centimeters and A to C is the whole 22, then the distance of D to C must be equal to 22 minus the 11.9, which we'll find is 10.1 centimeters. Okay, so now we know the opposite, and we also now know the adjacent as well. So we're still going to work with the tan. However, this tan now is going to be something, so if we separate this, so we'll say this is this half, and then this last part, we know that tan of x, so the unknown x here, is equal to the opposite, which is 9 centimeters, divided by the adjacent, which is 10.1 centimeters. And now x is going to be the inverse tan, so 10 to the minus 1 of 9 over 10.1. And that, when you put that into a calculator, if we do inverse tan of 9 over 10.1, becomes 41.7 degrees. And therefore we have worked out the angle x. And this one was a little bit harder because we had to do a few more steps in order to get there. But essentially we've just used the same thing but just done it multiple times. So hopefully that isn't too complicated. This is all the questions we're going to go through on trigonometry. If you have any more, please leave them in the comment section. I'll get around to them as soon as possible. And thank you for watching, and we'll see you next time.